I'm Kristoffer Escano.
We're from Engiana Ea2. This is our video presentation for the Engiana project under Dr. Nico. So our problem is, a species of bacteria was found to grow linearly which thrives at 37 degrees and at a pH level of 7. A group of nutritionists are trying to find out how the temperature and the pH level affect the growth of the bacteria. Initially, on a tank filled with 25 liters of distilled water, they diluted a food sample for the bacteria to grow in. They found out that at 37 degrees and at a pH level of 7, the number of bacteria happened to be 871 after 6.77 minutes. But the results obtained from their experiment, they tried to manipulate the conditions to decrease the rate of growth of the bacteria. On another tank, they prepared 25 liters of distilled water and added the previously treated 1 times 10 to the negative moles per liter acetic acid, coming in at a rate of 3 liters per minute, with the fluid going out from the tank simultaneously at the same rate. They wanted to obtain a pH level of 7 in order to slow down the growth of the bacteria, so they calculated the concentration of acetic acid needed for it to happen. The calculated concentration was 1.39 times 10 to the negative 4 mole per mole acetic acid per liter of solution. The nutritionists continuously added the increments of the acetic acid solution to the tank. They found out that the time needed to obtain the target is the same as the time needed to reach 40 degrees Celsius from 37 degrees Celsius. Then, due to the temperature and pH level manipulations done, they were finally ready to observe the rate of growth of the bacteria. As a result of their observations, they found out that the constant of proportionality of heating is the same as the growth rate. Is the process done effective? What is the number of bacteria after the same duration as that of the initial experiment?
So as we can see, the problem is a mixture of the concepts of mixing, heating, and growth. Now, what is required from us are the time needed to reach the target concentration in order to obtain a pH level of 5, the proportionality constant of the heating, which is the same as the proportionality constant of the growth, and the number of bacteria. Now, for the mixing, we have a 25-liter tank. We have a tank filled with 25 liters of H2O and an acetic acid that has a concentration of 1.0 times 10 to the negative 5 moles per liter coming in the tank at a rate of 3 liters per minute. Along with this, fluid is also going out from the tank at a rate of 3 liters per minute, which is the same as the rate going in. Now, for the differential equation, our formula is in minus out equals accumulation, or in minus out equals ds over dt. The rate of the substance going in, which has unit of moles per minute, is equals to 1.0 times 10 to the negative 5 times 3 liters per minute, while the rate of the fluid going out is S over 25 moles per liter times 3 liters per minute. S is the number of substance going in or going out. So manipulating this equation, we can make it look like a linear differential equation like this. We have ds over dt equals plus 3s over 25 equals 3.0 times 10 to the negative 5. Now, since we have this, we are now ready to look for the integrating factor. Integrating factor is equals to e raised to integral of px dx, which is e raised to integral of 3 over 25 dt, which is when we integrate this, it would result to this, which is e raised to 3t over 25. Now, knowing that now we can insert the integrating factor, the previous linear differential equation, knowing that this is the integral of the left side of the equation. We can now proceed to substituting the limits. While on the right side, we would still need to integrate the right side of the equation. Now, after substitution and calculations, we would arrive at the time 6.77 minutes, which is the time needed to obtain the target concentration.
In order to solve for the number of bacteria, we have to solve first for the proportionality constant, and we can solve that using the heating method. Given the differential equation formula for heating, we substitute in the room temperature, which is 42 degrees Celsius, is given in the problem. And we can put in the limits, which are 37 and 40 for the temperature, and 0 and 6.77 for the time. Then we can finally get the value of the constant of proportionality. Then we can solve for the period. So finally, we're supposed to find the number of bacteria after 6.77 minutes. So for that, we use the equation dx over dt is equal to k times x. So we put in the limits. Here we have limits from 1 to x. And on the other side, we have the limits from 0 to 6.77. So integrating both sides, we get this equation. Since we know the RK, so we simply substitute that into the equation. And then substitute the limits, we get ln x equal to 0.135 times 6.77